This is section 3.3, proving that lines are parallel. So if you remember from last section, in the last video, we looked at what we know is true about certain angles when lines are parallel. And we began with this postulate, which you don't need to write down again. If two parallel lines are cut by a transversal, remember a transversal is just a line that cuts through two other lines, then corresponding angles are congruent. So I marked two pairs of angles as congruent on my picture here, and I know that if I know that the top line is parallel to the bottom line. Remember, we marked parallel with those angles, with those arrows going in the same direction. If I know two parallel lines are cut by a transversal, then the corresponding angles are congruent. And corresponding angles, remember, are angles that are in the same relative position. And we also saw that if two lines are parallel, alternate interior angles are congruent, and same side interior angles are supplementary. What if, though, we want to show that lines are parallel? So we don't know already that they're parallel. We want to show that they are. We want to prove that they are parallel. What do we need in order to show that lines are parallel? It turns out that what we need is very, very, very similar to the results we got when lines were parallel. So we're going to have 5 ways to prove that lines are parallel. What I want you to do on your paper is write down numbers 1, 2, 3, 4, and 5, just like that. You might want to skip a line in between them, and we'll come back and fill in that list as we work our way through the video. So write down ways to prove that lines are parallel, then number 1, number 2, number 3, number 4, and number 5 underneath it. And we'll come back and fill it in as we discover what those ways are. The first way comes from this postulate, which should look somewhat familiar. If two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. Why that should look familiar is it's the reverse of the postulate we just looked at, the postulate from the last video, which said if two lines are parallel and cut by a transversal, then the corresponding angles are congruent. This time we have two lines cut by a transversal. We know corresponding angles are congruent, so we know those lines must be parallel. It's the reverse. What was the conclusion is now the hypothesis. It's now what we're starting with. It's in the if part of the statement, whereas it was in the then part of the statement. We swapped the if and the then, which doesn't always work, but with parallel lines it happens to work. So that means that if angle 1 equals angle 2, or angle 1 is congruent to angle 2, then line M is parallel to line N. And remember, writing two slashed lines like that means parallel. So if just that one pair of corresponding angles are congruent, then those two lines are parallel, and all of the other pairs of corresponding angles would then have to be congruent. So I don't need to show that all 4 pairs of corresponding angles are congruent. All I need to show is that one pair is congruent. Then I know that the lines are parallel. There's a shortened way. If we want to write this postulate in shorthand, like if we were using it as a reason and a proof and we don't want to write out every single one of those words, a shorthand way to write it, which I'll write here in orange, is corresponding, which I'll abbreviate like that, angles congruent implies parallel lines. Okay? So that would be a shortened way to write this postulate. Again, it's a postulate, so we assume it to be true without proving it. But if we assume that one postulate, we can prove the next several theorems. And this is the first way that we can show lines are parallel. So let's go back up to our list, and we will add this as number 1 on our list. If we want to show that lines are parallel, first thing we could do, one option, is to show that a pair of corresponding angles are congruent. one way to show that two lines are parallel is to show that one pair of corresponding angles are congruent. Okay? Let's find a second way to show that two lines are parallel. We have a theorem that says if two lines are cut by a transversal and alternate interior angles are congruent, then what do you think is true? The lines are parallel. So the reverse of one of our theorems from the last section. One of our theorems from the last section said if two parallel lines are cut by a transversal, then alternate interior angles are congruent. This time the theorem says if two lines, we don't know that they're parallel, if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. So in the case of this diagram, that would say if angle 3 equals angle 4, which is another way of saying angle 3 is congruent to angle 4, then line J is parallel to line L. If we want a shortened way to write this theorem, we could say alternate ALT period, interior INT period, angles congruent implies parallel lines. So if we know, or we can show, that one pair of alternate interior angles are congruent, then we can show that those lines that make those alternate interior angles are parallel. So that is our second way to prove that lines are parallel. Show that a pair of alternate interior angles are congruent. Okay, that's a second way. Third way. If two lines are cut by a transversal and same side interior angles are supplementary, then the lines are parallel. Surprise, surprise. Again, the reverse of a theorem from the last section, which said if two lines are parallel and cut by a transversal, then the same side interior angles are supplementary. This time, if two lines are cut by a transversal and same side interior angles are supplementary, then the lines are parallel. So in the case of this diagram, if angle 1 equal angle 1 plus angle 2 equals 180, which is another way of saying angle 1 and angle 2 are supplementary, then line K is parallel to line N. So in shorthand, same side interior angles supplementary implies parallel lines. So that's a third way to show that two lines are parallel. Show that a pair of same side interior angles are supplementary, meaning they add up to 180. Okay, two more ways to show that lines are parallel. In a plane, so we have to be in the same plane, two lines perpendicular to the same line are, let's think about it. If we know that J is perpendicular to T, line J is perpendicular to line T, and line K is perpendicular to line T, then they both form right angles with line T. Those right angles are themselves corresponding angles. They're in the same relative position above the horizontal line and to the left of the vertical line. So they're corresponding angles, and they are congruent if they're both right angles. They're both equal to 90 degrees. So this is just something that follows directly from our theorem that said if corresponding angles are congruent, then the lines are parallel. So these lines must be parallel. It's just a special case of corresponding angles being congruent if those angles happen to be right angles, so the lines are perpendicular. So if two lines are perpendicular to the same line, then those lines are parallel. So if J is perpendicular to T and K is perpendicular to T, then J is parallel to K. They're both perpendicular to the same line. So that is our fourth way to show that two lines are parallel, which is show that two lines are perpendicular to a third line. Okay? One more way to prove that lines are parallel. If you have two lines that are each individually parallel to a third line, then those two lines are parallel to each other. So think about what that means in this diagram. If M is parallel to N, if M is parallel to N, which I'll mark with one set of arrows, and M is parallel to P, I'll mark with double arrows, then this theorem says since both N and P are parallel to M, then they must be parallel to each other. N is parallel to P, which we can mark with a set of triple arrows. If M is parallel to N and M is parallel to P, then N and P must be parallel to each other. That is our last way to prove that lines are parallel. Show that both lines are parallel to a third line. That completes our list of 5 ways to prove that lines are parallel. In order to prove that last one, we would need 2 what I'm calling necessary theorems. And let's look at each of those individually. Somewhat intuitive ideas, but it turns out that these ideas are required in order for the rest of the geometry we're studying to work. We need this to be true. And it's very, very, very difficult to actually prove that this is true. But it's possible if you make an assumption. And that assumption is the postulate that we have just made at the beginning of this video. So the first of these theorems says that through a point not on a line, there is exactly one line parallel to the given line. So I have a line L drawn on the point P. This theorem says through my point P, which is not on L, it's clearly above the line, it's not on L, I can draw exactly one line that goes through P that's parallel to L. There's only one, is what this theorem says. I can't draw a second one that's going to be parallel to L. Because if I draw a second one and it's not P, it's going to be slanted. And if it's slanted, that's not a straight line. if it's slanted, then at some point it's going to intersect L. This one would intersect L down here, so it can't be parallel. This theorem says there's only one line that goes through P that's parallel to L. Seems intuitive, very, very difficult to prove on its own. Second theorem, through a point not on a line, there's exactly one line perpendicular to the given line. So through my point P that's not on K, there can only be one line perpendicular to K. There can only be one line that I could draw that would be perpendicular to K. Any other line I draw that goes through P can't be perpendicular to K. Okay, here are your immediate practice problems. We have this picture to the right. 4 lines, M and T are the somewhat vertical lines, N and K are the horizontal lines, and I've numbered 16 different angles there for you. Which lines, if any, so the answer might be none, which lines are parallel if you know individually each of these pieces of information? So these are 4 separate problems. Number 1, if I know that angle 1 equals angle 3, which lines, if any, are parallel? Number 2, if I know angle 6 equals angle 9, which lines, if any, are parallel? Number 3, if I know angle 3 equals angle 8, which lines, if any, are parallel? And number 4, if I know angle 6 and angle 10 are supplementary, which lines, if any, are parallel? State the lines that are parallel, or if none are parallel, write the word none. And please draw the picture on your paper. That is the end of section 3.3.